Today's video, we will be focusing on modifying a curved conveyor bend unit for a Lubing conveyor. A couple of things to note about a bend unit. First of all, if you ever have to modify the angle of this bend, the area removed or the section removed must be from the middle of the bend. And we will discuss more of that later. We cannot simply cut off of each end of the bend. There's an approximate 8-inch or 200 millimeter straight section on both ends of the bend that are required for the chain to properly transition from other components into the bend, which we will talk about later, has a special sliding profile, green profile, through most of the bend units. And that allows the chain to collapse for the slack side or the inside radius, and then also expand back out to tension as it exits the bend. If you modify and cut or remove this transition area, it can cause issues. So we will discuss today on how we measure to determine that angle and what steps are required to modify, to remove so many degrees of the angle from the middle and rejoin the bend for the best performance in your conveyor. What we've done here today is set up two imaginary sections of conveyor. The important thing here is this conveyor section is running in its proper alignment with whatever it needs to feed this way. This section right here is aligned with whatever is critical to the conveyor in this direction. These sections, they are loose. They are not in any kind of bind. There is no obstacle pushing one. If we make our measurements off of conveyors that are bound or racked, crooked, that will translate into the bend. It will not give us the most accurate bend angle. So ensure that the conveyor sections in both directions are running true, they are straight, and they are where the final location needs to be. So what we're going to do now, as you can see, this right here is a very small area for a bend unit to fit. And that is perfectly fine. We are not trying to cut a bend to fit this area. We are simply using this to determine our angle. We will take some measurements. Those measurements can then be relayed to your Lubing sales representative or Lubing engineering, and we will determine the bend angle and can also provide a drawing for how this bend unit needs to be measured, cut, and reassembled. So, step one, again, the conveyor is exactly where I want it to be. Nothing is pushing it, forcing it. Everything is level. This is where the bend unit will need to be placed. Now, again, we will either cut material away later to fit the bend. Sometimes you may have to add material to fill in the gaps. What we're going to do is we're going to take 4 measurements. We are going to measure the inside corner and try to be as accurate as possible with these, because these will translate into the accuracy of the bend angle. So I'm going to measure from this inside corner to this inside corner, which is a little bit better than 12 inches. Now I would be accurate to say 12¼ inches. I am then now going to measure from the outside corner, and I'm going to pull from the exact same point that I measured on the inside. So that same dimension here is approximately 24¼ inches. Now I am going to measure the 2 diagonals. Okay? Again, picking the same corner reference, we are at approximately 23 3/8, that dimension, and we are approximately 22 inches, that dimension. I will have recorded those dimensions. A simple sketch will do. That sketch can then be sent, again, to your Lubing representative, sales representative, or Lubing Engineering directly. Now, one thing to consider before taking these measurements. These are factory ends of these connecting parts, the straight sections. They have never been modified, so I am confident in the accuracy and that these are square across the ends. If these are not brand new connecting parts, you must measure the total length of both side plates and both side plates here. If someone has cut this unevenly, that will skew the angle dimension. If it has been cut, that is acceptable if both sides have been cut the same. Again, very important that that is a square cut along both edges at the ends of both conveyor sections that you are measuring from. Again, to recap, we measured the inside corner distance, the outside corner distance, diagonally, and again, diagonally. We have noted those on a simple sketch. Please include units, okay? We were dealing in inches. If you are dealing with millimeters, centimeters, whatever, please designate those units on this. The final piece of information that is required, what is the width conveyor that you are dealing with? The Lubing conveyor is actually standardized based off the chain link centerline dimension. This in particular is a type 350. The chain would be approximately 14 inches wide, but if you are unsure, just measure the outside width of the conveyor and just note that on your sketch that this is the outside of the conveyor width, and we can determine which conveyor you have. Once these measurements are received, we can lay out the particular angle that you require. All right, in this video, we're going to further discuss modifying a bend in the field. In the previous video, we spoke about recording the dimensions and how that is going to help determine the final angle. This is a sheet similar to what you would receive from engineering that has the values inserted that were recorded and presented to us from the farm sketch with the angle determination. Okay, that's just to confirm your dimensions before you modify the bend. Also included will be the actual cut dimensions to measure so that you can remove so many degrees from the bend unit that you have and then reassemble it. So, one of the things, again, we spoke about this in the last video, but it is very important to understand that each end of the bend has an approximate 8 inches, roughly 200 millimeters of straight section. This section cannot be removed from either end except in rare occasions where engineering has specified to do so. Okay? What we're going to have to do is measure so that we can remove the proper amount of angle or degrees from the center of this. The sketch we're working with today specifies that this particular bend, based off of these dimensions, ends up at 50 degrees. Okay? We are starting with a standard 90-degree bend. Lubing Systems provides standard bends at 90 degrees and 45 degrees. So you must have a bend greater than the angle that you will need or end up with after your measurements are taken. So what we're going to do now, we're going to lay out the dimensions that we can remove 40 degrees away from this 90 and be left with a 50-degree bend. This can be done with a tape measure. What we will do is we will measure along the inside radius to the dimension that is provided on the print that you will receive. I prefer, if possible, to use a measuring tape that is more flexible. This will allow you a greater degree of accuracy when making the cuts. The sketch we receive shows that we need approximately 20 3/4 inches from both ends on the inside radius. On the outside radius, we're going to be at 27.5 inches, measuring from both ends toward the center. So what we would do now is we would take our tape measure or seamstress tape or whatever measuring device that you have, and we will lay this out as accurately as possible. Make sure that you are not pulling straight. This measurement device, whatever you're using, needs to follow the inside radius as best as possible. Sometimes you can take a bend unit and stand it up on its end and allow it to lay in. That way, when you make your mark, it is as accurate as you can make it. So, if we were to measure the 20 3/4, we come along the inside and we make our mark. 20 3/4 would be here. So, for illustrative purposes, we are going to use a marker today. You can use whatever just for the camera. Let's say our mark ended up here. All right, we've marked our dimension, taking some sort of square or a ruler, straight edge, and I'm going to transfer, and I would then mark up the entire side of the side sheet to guide my cut. I would measure in, make my mark, measure in the same amount, make the mark. You should never receive a drawing that's going to have unequal measurements. Whatever we cut on a bend, it's going to be equidistant from both ends. For the inside, the same on the outside. Both of those dimensions for the outer radius will match. We are taking the absolute center out of this bend unit. So, once the mark is made, the line is scribed so that we have a good guide. We could use anything. We have customers who have cut it with a hacksaw or a handsaw, sawzalls. Just be careful. Whatever cutting tool you're using needs to be something that can be guided. You have to be very precise. When we make these cuts, the cuts need to be true so that when we put the bend unit back together, we do not have angle to where we're actually starting to rack the bend. Now, another consideration. If you are modifying a bend unit, this bend unit will have come with a bend modification kit. This is a set of threaded brackets and hardware required that once you have cut and removed the center section, you have a way to join the two halves back together. Make sure that you have these components before you cut the bend. We will go more into how these are cut, drilled later on. Again, to recap, we always measure as accurately as possible from each end. Equidistant on the inside radius, equidistant on the outside radius. We make our mark with a square. The cut edge needs to be as square as possible, okay? So the bend goes back together without the side sheets being misaligned. In this video, we'll be talking about how to strip down the bend unit and get it ready for cut. In the last video, we talked about measuring in, making our marks and everything, and that is our layout for what material we're going to remove. Before you just cut the bin, before you cut through everything, it is important that we remove the traverse and thread plates from one end of the bin and take a hammer or a dead blow rubber hammer and knock the sliding profile out of the bin unit. We want to remove that sliding profile so that once we make our cuts and we rejoin the bin, the sliding profile can go back in as one piece. Whatever length has been removed from the center of the bin, that profile will stick out. We can mark the profile, cut it, and now we have a bin that has one continuous sliding profile, even though it's been modified. This is the bin before. We marked it, we've done our layout, but before we cut, this is a bin where we have removed the traverse and thread plates from one end. That has allowed us to remove the sliding profile from all 4 locations within this bin. The next thing that will happen, we will take our layout that we have already marked and we will cut through the side sheet. This cut, again, it needs to be square. It needs to be a good cut so that when the 2 halves of the side sheet come back together, they butt up properly. Also, again, if you are modifying a bin, you should have received a bin modification kit, which comes with these brackets that are threaded and hardware to bolt the 2 halves back together. These brackets are sized. They will be installed in the middle, but just to show you, they are sized to fit in this area of the extruded side sheet. That's why standard thread plates, other components within the system will not work. These are purpose built for this. So this is a stripped down bin, ready to field cut, and we will show that process in more detail in the next video. In this video, we're going to cover reassembling the bin after the cuts have been made. In the previous videos, we detailed measuring, laying out your cut lines, removing the sliding profile to get the bin ready to be cut in the field. At this point, the bin that used to be a 90-degree, the center section has been removed to cut it down to 50 degrees in this case. A couple of things that we want to note. When making your cuts, you might have to put a slight angle on the cut so that the outer edge butts up and there is clearance on the inside. If the cut is crooked the opposite way, the interior edges will contact and it will actually affect the angle of the bin. You want to make sure that wherever your cut line was that you measured is the first point of contact when the 2 halves come back together. Again, the profile has been removed, the cuts have been made. Now, the plates that were provided as part of the bin modification kits, you can measure and mark the center line of the plate. You can then take the plate, lay it into the bin unit with the center line of the plate at the edge, and you can transfer or mark your holes to drill for the bolts that will hold the bin unit back together. These units have already been drilled. The bin unit will then be placed together. The plates mounted on the inside and outside radius, the provided hardware, bolts, washers, everything bolted together to hold this bin unit back in place. At this point, with the bin unit reassembled, we are now ready to reinsert the sliding profile. As you'll notice, we still have both of the end traverses and thread plates in this bin unit. In the earlier video, we specified that one of these would have to be removed so that the sliding profile can be slid out the end. The reason why this was put back into the bend unit was to stabilize this end. If we only have one cross member or traverse left, this being put back into the bend holds the bend stable while you're measuring, while you're cutting and everything. So this one end will have to be removed once more so that we can then come back, align our sliding profile with the notches in the bend unit, and begin to feed that profile back through the bend unit as one continuous piece. Once that is in, the bend unit is joined, everything is square, the profile is fully inserted all the way through the bend. We can then mark what is excess, cut that out of the way, and we do that for the top and bottom on both sides. All right, now we have our completed bend. It has been cut down, in this case, to 50 degrees. We've got everything joined together. The sliding profile has been reinserted as one piece. The excess was trimmed off so that it fits the length of the bend unit. Now, as you notice, we have brought this bend back to our original conveyor where we measured our gap. Earlier we said that we're not trying to make the bend fit the gap, but we were allowing the gap to tell us what the angle was between these two sections of conveyor. Now that the bend is here, we can position it to where it aligns with both legs of the conveyor. We can verify that the conveyor is still straight, the bend is correct. We can pull any final dimensions to confirm, and now we are ready to cut the conveyor. So we can pull a straight edge on where this side sheet of the bend is going to end relative to the conveyor on both sides. Again, when we cut the connecting parts, the straight sections of conveyor, they have to be cut square across. So wherever this line falls, you can make a measurement from the end of the piece to that line, transfer the line to the opposite side, make sure that you're aligning. Never cut unequal length legs to compensate. If it needs to be unequal, there's something else that needs to be addressed. But transfer your line, measure, come to this side, measure, transfer the line, and that is ready to cut. The same process is repeated on this side of the conveyor. We transfer our line, we measure, we come to this side of the conveyor, measure, transfer our line, confirm that everything aligns, and now we can cut this conveyor and insert this bend and bolt it into place. Now, once the conveyor is cut, you will need to transfer these two holes back here for mounting. After that, on certain bends, if the bend is long enough in angle, there may need to be a set of floor supports, a set of these legs added to the middle to properly support that bend. Depending on the width of the conveyor and the angle, a lot of times that third support is required here.